Alright, welcome. This is our first lesson in Chapter 2, 2.1, where we're going to talk about quadratic functions and models. So first, we have polynomial functions. And before I go on to define that, I want to just quick talk about what the word polynomial itself means. What it means is that it's a function or an equation with many terms. Poly meaning many, nomial really is parts. It's something with many parts, many terms. So a polynomial function, we're going to let n be a non-negative, that's one word, not two, integer, and the following terms, which we write as an, a sub n, a sub n minus 1, a sub n minus 2, and that keeps going until we get to a2, a1, and a sub 0. Now those are the little numbers that are to the bottom right, and the little variables, those are index values. So we have that, and we are going to say that they are real numbers, and specifically one of these, a sub 0, cannot equal 0. Then what we can say is the function f of x equals a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus, that's going to keep going until we get to a sub 2x squared plus a sub 1 times x plus a sub 0. What we can say about that is that it is a polynomial function. And then on the same page, I'm going to also put some information about a quadratic function. So what we can say is we can let a, b, and c be real numbers, with a being a non-zero number. The function f of x equals ax squared plus bx plus c this is a quadratic function, meaning that the graph is a parabola that either opens up or down. Now some characteristics of a quadratic are as follows. If A is positive, then we say that the parabola opens up. If A is negative, then the parabola opens down. Now a parabola, it's going to have a thing called a vertex, which is going to be a relative max or a relative min, depending on if it opens up or down. If it's a max, then it opens down, so A is negative. If it's a min, it opens up, so A is positive. Now, it's found using the terms A, B, and C from its form. How we find it is this vertex is found at an ordered pair, where the x-coordinate is found by taking the opposite of B and dividing it by 2 times the value of A. And the y value is found by taking what you found for x and putting it into your function, f of negative b over 2 times a. Now, parabolas or quadratics also have this thing called an axis of symmetry. And it's an equation. It's an equation where we write it as x equals negative b over 2a. And then we can also find zeros for the function, values that x can equal when y is 0. The zeros can be found using the quadratic formula. And if you need a quick refresher on what that formula looks like, we can find the zeros by setting x equal to negative b plus minus the square root of b squared minus 4 times a times c, and that's all divided by 2 times a. Now we're going to look at our first example here in a second. So this is going to be example 1. What we're going to do is we're going to sketch the graph of f of x equals 1/3 x squared and the graph g of x, which is equal to 2x squared. And we're going to compare them to y equals x squared. So let's do that. Let's start by making our coordinate plane, making our y-axis and our x-axis. Now here in black, I'm going to first take and graph y equals x squared. Now 0, if I were to plug 0 in for x, I'm going to get 0 back for y. If I plugged in 1 for x, I'm going to get 1 back. If I plug 2 in, I'm going to get 4 back. And then this is a parabola. If I plugged in negative 1, I'll get 1. And if I plugged in negative 2, I'll get 4. And I could keep going. 3 I would get 9, 4 I'd get 16, so on, so forth. I'm just worried about at least having a few points, and then we can connect our dots. So we've got y equals x squared. Now in blue, here I'm going to graph my g of x, which is 2 times x squared. So I'm going to take each point and I'm going to multiply it by 2. So I still am at 0, 0, but at 1, now I go to 2. Same with negative 1. At 2, I'm going to go to 8, and that is actually going to take me off the screen, but it's somewhere way up here. Almost directly at the top of my screen here. So let's connect our points. That's not very well. Okay. Alright, so in blue, we've got y equals 2x squared. In red here, I'm going to graph f of x. Now that 1/3 in front of x squared, that means each x value is going to be taken and divided by 3. Each original x value. So I'm still going to have a point at the origin, but now at 1, instead of being at 1, I'm going to put a point at 1/3. Same with -1. At 2, will be at 2/3. Which, same with -2. And then at 3, we could keep going. 3 is going to bring us to 1, same with -1. And that's just going to keep going. Now, if I were to continue and have to explain what's happening with these, f of x, the red one, it is shrinking y by a factor of 1/3. It's essentially taking every y value and dividing it by 3. G of x, our blue line, what it does is it takes y and stretches it by a factor of 2. And that's all we have to do for this. What we just put here in red and in blue, the words, that's what they asked, and then our graph. So we're done with example 1. Here in example 2, we have to identify the vertex and axis of symmetry of the function f of x equals 2x squared plus 8x plus 7. Now I'm going to start by finding my axis of symmetry, which I'm going to just abbreviate as AOS. So that's going to be a line, x equals, and before I even continue with finding my axis of symmetry, I'm going to first identify what my A, B, and C parts are. Now, in this, A is always the coefficient in front of our x squared term. So A is 2. B is the coefficient of our middle term. So in this case, it's 8. C is our constant, which in this case is 7. So our axis of symmetry is always found by taking negative b and dividing it by 2 times a. So in this case, we're going to take negative 8 and we're going to divide it by 2 times 2. Well, 2 times 2 is 4. Negative 8 divided by 4 is negative 2. So our axis of symmetry is the line x equals negative 2. And that's one part of what they asked us to do. The vertex is an ordered pair where the x-coordinate is negative b over 2a. The y-coordinate is just taking that value and putting it into the function for s. x. And we actually found negative b over 2a, finding the axis of symmetry. So now we can even plug that into our ordered pair. Let's take negative 2 and put it in for x to find the y-coordinate. So we're going to have 2 times negative 2 squared plus 8 times negative 2 plus 7. Negative 2 squared, that's 4. 2 times 4 plus 8 times negative 2 plus 7. Now we can do our multiplication. 2 times 4 is 8. 8 times negative 2 is negative 16, so we'll write 8 minus 16 plus 7. And if we do our addition and subtraction from left to right, 8 minus 16 is negative 8. Negative 8 plus 7 is going to give us negative 1. So our vertex is the point negative 2, negative 1. And they asked us to find the axis of symmetry and the vertex. So we're actually done with this. If they did want us to find the zeros, we could have done that by using the quadratic formula or some other methods. And I'll list those methods on our next page. So like I said in the last example, we can find the x-intercepts, which are also the zeros of a quadratic function, by solving the quadratic by either factoring, we could complete the square, or we can use the quadratic formula, which is my personal favorite. So we're actually going to look at example 3 next. We're going to identify the vertex and x-intercepts of the function f of x equals negative x squared plus 6x minus 8. And then we're going to sketch the graph. So on this page, we're going to first find our vertex and our x-intercepts, and then we'll pull up a page to graph it. So first, let's look for our vertex. So our vertex, remember, is a ordered pair where we take negative b over 2a, and then we plug it in to the function to find the x and the y coordinates. Now in this function we're given a is negative 1, b is 6, c is negative 8. So let's find that vertex. We're going to have negative 6 over 2 times negative 1. 2 times negative 1, that's negative 2. Negative 6 divided by negative 2, that's 3. So we've got the first part of our vertex, our x-coordinate. Now let's put 3 into the function and figure out what the y-coordinate is. So we're going to have negative 3 squared plus 6 times 3 minus 8. Well, 3 squared is 9. So we're going to have negative 9 plus 6 times 3 is 18. And then we're going to subtract 8. So negative 9 plus 18, that's 9. And 9 minus 8 is 1. So our vertex is at the point 3, 1. We will continue with finding our x-intercepts in our next video.